In this video, we simulate the unconditional jump instruction of the Scott CPU. For this purpose, we have built a simulation circuit in Circuit Verse Simulator. This video is part of the How Computers Work Building Scott CPU YouTube playlist. The links to the playlist and to the circuit are in the description. We have two kinds of unconditional jump instructions. The first is this, which says jump to the instruction contained in register B, R2 in our case. The opcode is 0011, producing the first unconditional jump signal. The other unconditional jump instruction is this one, which says jump to the address specified as follows. So this instruction takes 2 bytes. The opcode is 0100, producing the second unconditional jump signal. Let's see the control signals for the first unconditional jump instruction. So jump R2, for example. With this instruction in the instruction register, this signal is high, and when the fourth step arrives, this AND gate is open, giving an enable pulse to R2, putting the address on the bus, and a set pulse to IAR to acquire the address inside the instruction address register, which now is ready to jump to the next instruction. When the second unconditional jump instruction is in the instruction register, we have these signals I. So when the fourth step arrives, this AND gate is open, giving an enable pulse to IAR and a set pulse to MAR. In this way, we put the address of the next instruction in MAR, and this address is the address of the cell containing the XX address we want to jump to. So in the fifth step, we just give an enable pulse to RAM and a set pulse to IAR to acquire the address of the instruction we want to jump to inside the instruction address register, so as next instruction. So let's see the first unconditional jump instruction, so the jump to the register, so to the address contained in a register. In our case, the instruction, so in Scott CPU, the opcode is 0011, 00 because the register A is not used, and as a register B we put the register 2, so 10. This means jump to the address contained in register 2. So now we put this instruction inside the RAM and we perform the simulation. We put this instruction in the address 0, so we put 0 on the bus and we give a set pulse to the instruction address register and we put the address 0 inside the IAR because this register has to point always the next instruction. And we put the address 0 in the memory address register. So now the RAM is pointing the cell 0 where we are going to put the instruction. So 0011 and as a register B 10. So this is our instruction and we give a set pulse to the RAM to put it inside the RAM. So now we have our instruction in the RAM. Let's see. Okay. So this instruction, as we said, jump to the address contained in R2. So we are going to put inside R2 a particular address that we want to put, that the instruction will put inside the instruction address register. So we can say this is our address. I put this in the bus and I acquire it inside R2, giving a set pulse to R2. So we free the bus, we just check what there is inside R2. Okay, and there is our address. We check what there is inside the instruction address register, and there is the cell 0. And we check what there is inside the RAM, and there is our instruction. So now we can perform the instruction. We can give a reset pulse to this stepper cycle and we run a whole stepper cycle, and we know that in Scott CPU every instruction is performed in one step per cycle. So we perform just this instruction, and then the circuit stops. So we give a pulse, and you see the step per cycle is running, and now after the sixth step it blocked, it stops. So we can check what there is inside the instruction address register, giving an enable pulse and putting the contain byte, the byte inside the instruction address register on the bus. So we give a steppers enable pulse, and we see that inside the instruction address register there is the address we have put inside R2. So the instruction worked well, because the purpose of this instruction is putting inside the instruction address register the content of the R2. So the program will jump to the address contained in R2, and so the simulation worked well. Now we see the second unconditional jump instruction, so jump to the address. In particular, the opcode is 0100, and we don't use reg A and the reg B, so 0000, and this is the jump address, and the address we put the address next to the instruction. So for example, the address can be 011 and all other bits at 0. So this is the address to which we want to jump. So at the end of the simulation, we want to find this address inside the instruction address register. But first, we have to put these 2 bytes inside the RAM. So inside the cell 0, for example, we put the first byte, so the instruction, the jump instruction, and in the address 1, we put the address to which we want to jump. So first of all, we put the address 0 on the bus, and we acquire it inside the instruction address register, because this has to point to the next, always to the next instruction, and we put this address in the memory address register. So now the RAM is pointing to the cell 0. In the cell 0, we put our instruction, so 01 and all the bits at 0, and we put this inside the cell 0, giving a set pulse to the RAM. Now we want to go to the next address, so the address 1, and here we want to put inside the address 1, inside the cell with the address 1, we want to put the address to which we want to jump. So first of all, the address 1, we have to put the address 1 inside the memory address register. Okay, and second, we want to put this address, okay, inside the cell 1 of the RAM. Okay, and we do this, giving a set pulse to the RAM. Okay, and now we free the bus. So now these 2 bytes are inside the RAM, and the instruction address register is pointing to the first instruction. And at the end of the simulation, we want to find inside the instruction address register this address here, 011, and all the other bits at 0. In this way, the program jump to this instruction, to this address here, which will be next in the program. So let's run this simulation, giving a reset pulse to the step per cycle. In this way, we perform just one cycle, because in Scott CPU, every cycle we perform an instruction, and we want to perform just one instruction. So, given a pulse, you see the step is running, and after 6 steps, it stops. We go down here, and we see what there is inside the instruction address register. So we give an enable pulse to the instruction address register, and we find inside the instruction address register the address to which we want to jump, which is the address next the instruction, the jump instruction. So the simulation worked well.
Please leave me a comment, let me know if you liked this video, make sure you put a thumb up, click the notification bell and subscribe to my channel.